Hello, my name is Menghisteab, and this is my Lab 1 report on constant velocity. The purpose of this lab is to investigate real-world situations of constant velocity using video analysis and comparing computational modeling through GlowScript to observations recorded in Tracker. Experimental setup and observations. For this experiment, I used an American flag themed toy car as the system being studied. At the beginning of the video, I applied a push to the toy car towards the right. After the push, the car moved across the table with approximately constant velocity for a portion of its motion before friction gradually caused it to slow down and eventually stop. The motion was one-dimensional and horizontal. The camera remained stationary throughout the recording, and a positive X direction was defined as the direction to the right. The surroundings acting on the car included Earth's gravitational field, the table surface, and friction between the car and the table. An iPhone 12 was used as the calibration object so that Tracker could convert distances measured in pixels into real physical distances. From observation, the position of the toy car increased approximately linear with time, suggesting motion at nearly constant velocity. Tracker video analysis. After recording the video, it was imported into Tracker for analysis. First, a calibration stick was created using the known lengths of the iPhone so that distances could be measured accurately. Next, the coordinate system was established with positive X pointing to the right. The position of the toy car was then tracked every 5 frames throughout the motion. Tracker recorded both X position and Y position values. Since the motion was intended to be horizontal, the X position data was the primary focus. Small changes in the Y direction occurred mainly because of slight inaccuracies when placing the tracking point on the car. The X position versus time data collected from Tracker was then used to construct the computational model. Computational model. Using the data collected from Tracker, I created a computational model in GlowScript. The initial position of the toy car was measured at 0.014 meters, and the initial velocity was determined to be approximately 0.4218 meters per second. These values were entered into the GlowScript program, and the model is based on Newton's first law of motion, which states that an object will continue moving at constant velocity when the net force acting on it is 0. For this model, the net force was set equal to 0. As a result, the velocity remained constant throughout the simulation. The program repeatedly updated the position of the object using this velocity and generated a predicted position versus time graph. This allowed the motion to predict how the toy car should move if it experienced constant velocity motion. Position versus time data. This graph compares the experimental data from Tracker with the predictions generated by the GlowScript model. The blue points represent the observed position data collected from the video analysis, and the orange points represent the positions predicted by the computational model from GlowScript. Overall, the two data sets show very similar trends. This indicates that the computational model accurately predicted the toy car's motion during the constant velocity portion of the experiment. Although the agreement is strong, there are small differences between the two data sets. These differences are likely caused by friction acting on the toy car, slight calibration errors, and uncertainty when collecting the tracking point in Tracker. Because the model and the experimental data agree closely, constant velocity is a reasonable approximation for the motion being analyzed. The first discussion question asks, what would happen if the axis were flipped? If the positive X direction were reversed, the position values would become negative instead of positive. However, the overall shape of the graph will remain the same because the motion itself would not change. The second discussion question asks what it means that the model worked when the net force was set to 0. The model was able to accurately predict the motion because Newton's first law states that an object moves with constant velocity when the net force acting on it is 0. This suggests that during the analyzed portion of the motion, The forces acting on the toy car approximately blended well enough for constant velocity to be a useful approximation. To conclude, the toy car moved with approximately constant velocity during the analyzed portion of the experiment. The computational model created in GlowScript successfully predicted the observed motion. The comparison between the tracker data and the model predictions showed strong agreement, demonstrating that the model accurately represented the motion of the toy car.